Hi, we'll discuss libraries and modules today. It's an important chapter in that you'll be using modules and libraries in a lot of programs. Ahead, when I do projects, they'll become an important part of the program. In today's video, we'll discuss Python's inbuilt libraries. We'll create and import modules, and we'll also create and import libraries. Python's standard library contains built-in modules. These provide standardized solutions to many problems that occur in everyday programming. If you want to be a programmer, it's a great idea to know about the libraries and modules. We're going to look at some of the most commonly used libraries. There's matplotlib, which is a library that helps with data analyzing and is a numerical plotting library. Pandas is at the heart of data science and it provides high-performance data structures and data analysis tools. There's NumPy, which has advanced math functions and a rudimentary scientific computing package. There's requests, which is a Python library that lets you send requests, add headers, form data, multi-part files, and parameters with simple Python dictionaries. Beautiful Soup has an excellent XML and HTML parsing library for beginners. iGame provides an extremely easy interface to the simple direct media library, platform independent graphic, audio, and input libraries. To use the Python standard libraries, we need to know a little bit about pip. Pip is the package manager for Python libraries, and if you have Python version 3.4 or later, this comes included by default. I'm now going to demonstrate installing a library. To do that, we need the Python environment and an internet connection. If you're using the Anaconda Navigator, you'll find that a lot of libraries will come inbuilt, so you don't have to install them. We're now going to install a library from the Python standard library. And to do that, we first need to go to the scripts folder where pip application is located. We start by going to IDLE and we're going to use file open. This is an easy way to find where scripts is. By default, it opens the folder where Python is located. And in this, we'll see that there's the script folder. Now, if we want, we can simply copy Control C here, copy the path. Then we just close this and go to the search bar in the start menu. We can write CMD here. And once we do that, we can write CD, which means change directory, and copy the entire path here. Now, once we do that, we'll be in the path that we need. Now, if we want to install, for example, pandas, it will start installing pandas for you. It may take some time, and once it's finished installing, the cursor will be blinking after the prompt that you started with. Suppose we want to install, we now want to install matplotlib. We say pip install matplotlib. And we'll see that it's already installed on this computer. So it says requirement already satisfied, and it shows you the cursor once again. So that's how you can install a library. We're now going to use the matplotlib library in an example. We use import matplotlib.pyplot. Pyplot will give us functionalities to plot a graph. And we use the keyword as. We also give a variable name, which is called an alias. And when we do that, we use the alias to use all the functions from this particular library. So we say plt.plot x, y. It'll plot a graph with the values of x and y. When we say plt.show, it'll output that plot. Now, once we run this program, we'll see that it outputs a graph. Another way to do this is to use the keyword from and use the name of the library. We use the keyword import and then we say pyplot as PLT. Now, this alias can again be used in the same way as we did before, and this statement will work exactly the same way as the one we saw earlier. We'll now look at creating and importing modules. A module is a file with a .py extension, and most of the times it contains some kind of functions and variables which can be used in other programs by importing them. Now, we've been creating modules for a long time, so it's not difficult. Let's look at an example. We're going to start with modules, and modules are nothing but files with a .py extension. So basically, you've been creating modules ever since the day you started writing files in Python. We begin with an example where we are going to create a file which has a function called insertion sort, and it takes the parameter as a list and sorts it. We are going to save this file with a .py extension, insert.py. We can use this module in another file. We open a new file and say import insert, and we're going to use the print statement with insert dot insertion sort. That's the name of our, and we're going to give it some numbers. So we've basically imported the module. We've used the function from this module and passed the values to it. Now, when we save this, sort.py, we're going to run this, and we'll see that it has sorted the list that we gave it. So this is as simple as this, creating a module. Another way to import this module is using an alias. We can say import insert as ins, and instead of insert, we now use ins here. We run this module, and we'll see that again, it has sorted the list that we passed. We're now going to create another module which will contain a function bubble sort to sort a list. We open a new file, write the module to bubble sort. We're going to save this as bubble.py. We'll now create a new file which we'll use to import bubble and use the function bubble sort to sort a list. And once we've done this, we're going to save this file as sort.py, and we run this module. We'll see that the list is now sorted. We can also change the same file and include the module insert, which we created earlier. We can also print insert.insertion sort. We're going to pass the same list here, and we are going to save this file and run this module. We'll see that now the list has been sorted once by bubble sort, once by insertion sort. So at one time, we can import more than one module and use the functions within those modules. We'll now create a module which includes both a function and a variable. We'll now create another module, and we are going to define in this module one function called welcome message. We also have a variable which is a dictionary, and this dictionary consists of keys as numbers, and the values are dictionary, a nested dictionary that is, and this consists of name, age, and class. Now we'll save this file, that is this module, and we'll call it student.py. That's the name of our module. We'll now open a new file in which we are going to import student, the module. And if we want to use the variable, we'll use from student, that is the student module, import student record, which is our dictionary. Now, if we use the print statement and we can print the student rec value of 1, we can also print from that nested dictionary the key 1 and the name in key 1, and we can pass the student rec to key and the name in this nested student rec to welcome message to get the output as hello and the name. So when we save this file, we're going to save this file as import std.py, and when we save it, we'll run this module. So in the output, we'll get a dictionary for the first print statement. For the second print statement, we'll get the name in student rec 1, which is Rahat. And when we call the function, the output will be hello and the name in student rec 2, which is Jatin. To create a library in Python, we follow some simple steps. We begin by creating a folder or directory and giving it a name, which is actually our library, and preferably we should name it after its operation. We then put some modules in it. We can also add sub-packages or other folders which are libraries within another library. We finally add a file which indicates that the directory or folder is a library, and this file is called the init.py file, and it could be left blank. It's written with 2 underscores before and after with a .py extension. Whenever we import a library in a program, the interpreter first looks in the current directory. Then it looks into Python path, which is an environment variable with a list of directories. Finally, it looks into the installation dependent default directory. The directory site packages is the target directory of manually built Python packages or libraries. We'll start by creating a library. To do that, we open the path lib site packages, which is a folder where our libraries can be globally available if we create one in this path. So we create a folder called factorial, and now that we've created the folder, we are going to put some modules in it. We start with the first one, which is basically to find the factorial of a number. We've got a function here called fact, and it takes a parameter n and calculates the factorial of n using iteration. We are going to save this in our folder factorial, and we go to that factorial folder and save this as fact underscore I dot py. So once we do that, that's our first module in the library. We'll now create the second module, open a new file, and in this, again, we have the same function, but this time we are calculating the factorial of n using recursion. So we're going to save this in our factorial folder. So we go to lib, site, packages, factorial, and save this as fact underscore r dot py. So this is our second module. Now that the modules have been saved in the folder, we'll convert it into a library or a package by adding the init file. So we go to the folder factorial, and we'll save this blank file with the name underscore underscore init underscore underscore dot py. So the moment we save this, we've actually now created a library and we'll be able to import it. We'll now open a new file to import the modules from our library factorial. So we say import factorial dot fact underscore I, that's our module, as fi, which is an alias we're giving here. And we can also use the other statement, that is from factorial, the name of the library, import, and we give the name of the module fact underscore r as fr. And we'll now use the print statement, and then we're going to use the alias fi and use the function fact, which is there in our module. We'll also use the print statement with fr, which is our other alias for fact underscore r module. And notice that both of them have the function fact, but it will be easily resolved because of the concept of namespace that we did earlier. We'll save this file, and we can save it anywhere. So we're going to save it on the desktop, saying check fact.py. And once we've done that, we are going to run this module, and you'll see that both of them will give the same output because it's the factorial of 10. Hence, the library is working. We'll now see how we can create a library with sub-libraries. We open the path, site packages, and we are going to create a new folder called fact sort, and this is going to be our library. And what we need to do here is we're going to first save a file, that is the init file in it. So we're going to save within that folder the fact sort folder. We are going to save this underscore underscore init underscore underscore dot py, and this is a blank file. We've saved it just to create this library. We'll now copy the libraries that we created earlier into this folder, and that will become the sub-library in this library that we've created. So we have factorial, which we'll copy and put in fact sort. We'll also copy sort library into fact sort. So now we have the library fact sort, which has two sub-libraries, factorial and sort library. So once we've created this library, we can import fact sort dot factorial dot fact underscore I as fi, and we can also say from fact sort dot factorial import fact underscore r as fr, and we use print statement fi dot fact and we say print fr dot fact. You can save this file as check.py. So we save this and we're going to run this file, and we'll see that again it gives us the output. Even though these are now sub-libraries, we can still call them. We'll now import the module student from the sub-library sort library, which is actually inside the fact sort library. And we do that with the import statement, and we create an alias here as std. So std is our alias, and we use the from statement from fact sort library dot student import, and we're going to import the variable dictionary here, student rec. We're going to output once again the value for student rec key 1, and we're going to also output the value for name from within the nested dictionary. We'll pass the same thing, that is student rec value for 2, and we'll pass the value for name as parameter. And once we do this, we can save this, and then once we run this module, we'll see that once again, it gives us an output where in the first print statement, it outputs a dictionary. For the second print statement, it will output the name from the dictionary, and it's also going to output hello and the name for the second key value. So that was a little bit about Python libraries and modules. I hope you understood. I'll be using some libraries when I discuss projects. Do subscribe to keep watching.